Today we'll be looking at the surface area and volume of a sphere. A sphere is the set of all points in space equidistant from a given point, which is a very similar definition to a circle, except that a circle is all the points in a plane equidistance, where this is all the points in space equidistance. The point is called the center of the sphere. The radius of a sphere is a segment from the center to a point on the sphere, just as the radius of a circle is a segment from the center to a point on the circle. A chord of a sphere is any segment whose endpoints are on the sphere, and a diameter of the sphere is a chord that goes through the center. So these definitions are very similar to definitions of a circle. The surface area of a sphere. Surface area of a sphere is 4 pi r squared, where r is the radius. So we know that the area of a circle is pi r squared, so for the surface area we need 4 of those to cover the outside of this sphere. So find the surface area of this sphere. Since surface area is 4 pi r squared, we simply have to plug in our 8 squared. We get 256 pi. That's approximately 804.25 if you're going to estimate it. Standardized test. The surface area of a sphere is 20.25 pi square centimeters. What's the diameter of a sphere? So in this one, we're going to have to think, excuse me, we're going to take our formula for the surface area, we're going to plug in, and we're going to solve for the radius first. Once we get our radius, then we can solve for our diameter by multiplying by 2. So our diameter is 4.5, which is B. So here's one for you to try. Diameter of sphere of 40 feet. Find the surface area of the sphere. The answer is that the surface area is about 5,028.56 square feet. How did we get that? We said that the surface area is 4 pi r squared. If the diameter is 40, then the radius is 20. So what we get is 4 times pi times 20 squared. The surface area is 30 pi square meters. Find the radius. We get 2.71. How? We have 30 pi is equal to 4 pi r squared. So we divide 30 pi by 4 pi. Notice our pi's cancel. This becomes 15 halves is r squared actually. So we would need to take the square root in order to get r. So that comes out to be approximately 2.71. If a plane intersects a sphere, the intersection will either be a point, if it's tangent to the sphere, or a circle. Notice down here, we have a plane cutting through a sphere. It will be a point, or it'll be a circle, and if that plane happens to go through the diameter, we call it a great circle because it divides that sphere into 2 congruent halves, and we call those halves hemispheres. The circumference of the great circle is the same as the circumference of the sphere. In a sport called spheering, a person rolls down a hill inside an inflatable ball surrounded by another ball. The circumference of the outer ball is 12 pi feet. Find the surface area of the outer ball. The circumference of the outer sphere is 12 pi feet. So the radius is 12 pi divided by 2 pi, which is 6 feet. Excuse me, which is 6 feet. So we'll use our formula for our surface area, and we get it's 144 pi, or about 452.39. In example 3, the circumference of the inner ball is 6 pi, so find the surface area of the inner ball. it would come out to be about 113.10. Now let's see, how did we do that? If our circumference is 2 pi r, so if our circumference is 6 pi, we can divide by 2 pi and we get a radius of 3. So our surface area is 4 pi times 3 squared, which comes out to be 36 pi, or about 113. The volume of a sphere. The volume of the sphere is 4/3 pi r cubed, where radius, r is the radius of the sphere. So remember, our surface area was 4 pi r square. Remember, we have to have a cube involved in order to have volume, and so instead of just 4 pi r cubed, it's 4/3 pi r cubed. Soccer ball diameter 9 inches, find its volume. First we need to find the radius, and now we're just plugging into the formula, and we come out approximately 381.70 when we do the math involved. The volume of a composite solid. What we're talking about here is taking the volume of this cylinder and taking away part of it. So this is hollowed out is what we're looking at. It's sort of like a dog bowl or something, where it comes straight down for the cylinder to give stability, but it's hollowed out to put the dog food in. So what we do, volume of a cylinder, we know is pi r squared h minus, and since this is a hemisphere, we only need half of the sphere, half of 4/3 pi r cubed. So this is just a matter of plugging in. Since we know our radius and we know our height, they're both 2 inches, so we plug in and solve the equation. So here's one for you to try. The radius of a sphere is 5 yards. Find the volume of the sphere. How did we get that? Remember, our volume is 4/3 pi r cubed. So if our radius is 5, that's just 4/3 pi times 5 cubed. A solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and a height of 5 meters. Find the volume of the solid around your answer. This one will take a little work. Comes out to be 7.33. Now, how did we get this? What we need to think about is basically what we're talking about is an ice cream cone. We have a hemisphere of a radius of 1, so here is my radius. From the center to the outside is 1. And the cone has the same radius, but the cone has a height of 5. So what we need is the volume of a cone. Remember, the volume of a cone is 1/3 of the base times the height. And my base is simply a circle, so that's 1/3 pi r squared h. And to that, we need to add the semicircle. We said that is the volume of a circle, but it's only half of it, so 1/2 multiplied times 4/3 pi r cubed. So we can plug in everything here. 1/3 pi times radius is 1 squared times 5 plus 1/2 times 4/3 pi times 1 cubed. And that's where we get our 7.33.